Okay, as promised, here is another gas law stoichish type problem. Hopefully you can see all of the corners. My camera is a little crooked today, having issues. Anyway, it says 75 grams of hydrogen reacts with 62 grams nitrogen at a temperature of 1250 degrees Celsius in a 35,000 centimeter cubed vessel. Find the partial pressure of all that remains post-reaction and find the total pressure inside the vessel. Phew! Lots of stuff going on. So there are a couple of different ways you can approach this problem. First off, I see that two things are reacting. So that means that I'm going to have to consider not only these two things, but their product gas. So let's go ahead and figure out that reaction if we can. Hydrogen is one of our diatomic elements. It can never be by itself, so hydrogen gas is written as H2. Nitrogen, same deal. And when these two react, this is actually called the Haber process, the process by which they make ammonia for fertilizers and things like that, and it has to be done under very high temperatures and pressures. So, just FYI. All of these are gases, so when it says find the partial pressure of all that remains, that means we're probably going to have at least two gases that will be remaining after the reaction has completed itself. So let's balance this. Let me see what I got here. 2, 3, and then these are all gases. So just looking at the rest of the problem right quick, I'll do this in a different color just so you can see it a little better. We have a temperature. I'll write that over here. We'll list our variables. 1250 degrees Celsius. Now remember, Celsius not good enough. I can't use any temperatures in Celsius. Got to go to Kelvin. So if you add 273 to this, we end up with 1523. Centimeters cubed is a volume unit, but centimeters cubed is not an acceptable unit. Since this is a single situation, I've got nothing changing. I just want the pressures, and they give me the temperature and the volume. I know this is a Pufner problem, so that's why I'm being particular about my volume unit. So 1,000 centimeters cubed is the same thing as 1,000 milliliters is the same thing as a liter. So this is 35 liters. My N, I don't know. I'm going to have several of them, in fact, since I want the partial pressure of everything that remains. So I haven't found my N yet. The problem asks me for the partial pressures of everybody. That's not right that way. So those two variables will not change, but my pressures and my N's will. So back over here. 75 grams of hydrogen, 62 grams of nitrogen. Well, those two are going to combine to form my ammonia, but I don't know how much. This is a limiting reagent problem, so we got to figure out who runs out first. So let's start with the hydrogen just because we can. Regular old stoich, ready, set, here we go. Convert to moles. Oops. Mole ratio helps us convert from reactant to product. And that is a very large number of moles. But I don't know yet if that's the limiting reagent. Let's go check out the nitrogen. Same deal. Convert to moles. Mole ratio gets me from reactant to product. So this is the smaller number. That makes nitrogen my limiting reagent, means nitrogen is going to run out first. This means that all that remains post-reaction is going to pertain to my ammonia and to my hydrogen. This guy is going to run out. So this is going to be my N. I'll label it NNH3 so I know that pertains to the NH3. So let's go ahead and figure out the partial pressure of my ammonia gas. So this is Pufner, as we talked about before, so we'll say P B equals nRT. I'm looking for P. So I'm going to plug in my N here times that R constant times my temperature, all divided by my volume. And let's see, I'm going to get a pressure. I'm just going to relabel this so I remember what it was. So this is a partial pressure. Since it's not everything that's happening in my box, this is just a piece of it. So that is my partial pressure of my ammonia gas. But it asks for everything that was in that container. And as we already said, there's more than just the ammonia left in that container. I had an excess reagent, so this gas is present too. This means I'm going to have to take my amounts of ammonia and backtrack to figure out how much hydrogen I actually used. So, same concept. We're going to use our chemical equation. If you remember back up here, between ammonia, and hydrogen, 2 to 3. So 2 moles of hydrogen, 2 moles of NH3, my apologies, to 3 moles of hydrogen. Now we have a slight dilemma because this is going to give me hydrogen in moles, but the amount of hydrogen I started with is in grams. Can't subtract apples and oranges. So you can either take this step all the way to grams, subtract, then convert back to moles, or we can take that 75 grams, there it is, that the problem gave us to begin with and convert that to moles. Personally, I prefer that one, mostly just because I like staying in the same unit as long as humanly possible. So let's see, 4.4254 times. That's 6.6381 moles of H2 that we used. Let's see how much we started with. 75 grams. Convert that to moles. 75. I started off with 37. So if I started with 37, and I used 6.6 roughly, that means, you can't see that number, I have 30.4961 moles of hydrogen left over. That's how much I didn't use. Yes, I know that's a lot. I made this reaction up off of my top of my head, so my numbers are a little wonky. Sorry about that. So that's going to be the N that we're going to use for our second partial pressure. Temperature and volume have remained the same. So same deal. Except now we're going to use this N. R is still R. Temperature is still the same. Volume still the same. Plug that into your calculator and we get a partial pressure of hydrogen as a really big number, my goodness. Now, I haven't done sig figs for either of these. I apologize. Both of these should have no more than 3 sig figs, so they are off a bit. But just to continue numerically speaking, these are both partial pressures. The problem also asked us not only for the partial pressure of everything that remains in there, but also for the total pressure inside the vessel. If you remember from the notes, we had a law called Dalton's law of partial pressures. And so that just required that we add everything together. So I'm going to take my partial pressure of my NH3 plus my partial pressure of my hydrogen, add them together. We'll do sig figs this time. And that is the total pressure inside the container. See, I told you this was done under high pressures. So that was a little bit of a doozy of a gas law stoich problem. And again, the stoich usually comes in determining the amount of something that you have. So be sure to stop and consider what you're actually measuring in your gas law problem. The temperature and the volume have to pertain to gases. So look for gases in a problem. If you've got more than one, see if the problem specifies. Sometimes they'll say collecting the carbon-containing gas or collecting the toxic gas if there's chlorine in there. This one asked you for the partial pressure of everything that remained after the reaction was finished. So this means that these are any and all product gases. So if there's more than one, got to consider those. Also, any excess reagent gases. So lots of things to think about. Again, if you have questions for me, please leave them in the comment box and I will get back to you as quick as I can. Happy stoiching!